This is Chapter 4-6, Completing the Square. We are going to find a new way of solving a quadratic equation today, and we can use this whenever we want, really, but especially when factoring doesn't work. This is definitely an option to take. Before we get into completing the square, let's backtrack a little bit and solve a couple of our old ways. The first way is the square root method, which when you're solving, remember, I want you to ask yourself those questions. What are we solving for? X. How many are there? 1. That's good. And when it's good, remember, we're going to do SADMEP, the reverse of PEMDAS. So we're going to get rid of any subtraction or addition. Well, there isn't any. And then some multiplication or division. Well, there's a 4 being multiplied, so let's divide both sides by 4. And that's going to give me x squared equals 5. And then to get rid of squared, we're going to take the square root. And remember, when you square root both sides of an equation, on one side of the equation, the square and square root cancel out. The other side gets a plus or minus. So we have an answer of plus or minus square root of 5. I can't simplify square root of 5 any, so we leave it alone. Or if you want to be a little bit extra, you can go ahead and write it out as 2 separate answers. Let's try another one. All right, what are we solving for? X. How many are there? Just the 1. That's good. So we're going to SADMEP. We don't see that minus sign yet because it's inside the parentheses. I want you to treat parentheses like a curtain. So I asked myself, are there any addition or subtraction? Nope. Multiplication or division? Nope. So I have to get rid of that exponent. That's square root both sides. And remember, when you square root both sides of an equation, on one side of the equation, the square and square root cancel out. The other side gets a plus or minus. All right. And now that the parentheses are gone, now I can see that minus sign. And I can say, oh, got to move the 2 over by changing its sign. And we put it in front of the plus or minus. And there we have our answer. X equals 2 plus or minus the square root of 6. That is actually 2 different answers. But you could leave it like that. It's fine with me. Or you could be a little extra and write it out as 2 separate answers. And then we learned about solving equations by factoring. We still go through the questions. What are we solving for? In this case, n. How many are there? 2. Well, that's bad. Are they like terms? Nope, that's worse. When we go from bad to worse, the only way we know to solve right now is by factoring. And we cannot factor unless it is set equal to 0. So I move that 99 over. And then I make 2 parentheses. And I try to figure out what multiplies to 99 and subtracts the 2. And there's our 2 factors. Once we have it in factored form, we take each factor and set it equal to 0. And then we solve. 2-step process. Move the number over by changing its sign, and then divide by the number in front of the variable. And you get your 2 answers of n equals 9 and n equals negative 11. But sometimes we get a trinomial that's set equal to 0 that can't be factored. You know, I ran through all my questions and I realized I have to factor, and this one's not factorable. 1 and 20 can't make 4. 2 and 10 can't make 4. 4 and 5 don't make 4. So we're kind of in trouble. So you have to learn some new ways, and I'm going to teach you a couple of new ways, and today's new way is completing the square, which means I want to turn this into something squared. All right? So let's get at it. Before we get to actually completing the square, let's start with the end product. This is what I want them to look like. I want it to look like this. I want it to look like this, where we only have 1x because I can solve for 1x. I can just do the square root method. But even before it looked like that, it was a trinomial. And if you FOIL out these perfect square terms here, you would get x squared plus 8x plus 16. You'll get x squared plus 14x plus 49. X squared minus 4x plus 4. X squared minus 12x plus 36. All right? I want you to notice something about each of these numbers. These are called perfect square trinomials. And in perfect square trinomials, you notice that the first and the last term are always perfect square numbers, which makes sense because I'm squaring the first term to get the first term. I'm squaring the last term to get the last term. So it kind of makes sense. But the even more important is look at the relationship between your middle term and the second term of your binomial. If you notice, it is always half. So if you start out with the trinomial, if you want to figure out what the second term of the binomial is, take your middle term and you just cut it in half. So here I have part of a trinomial. I have the first two terms, the ax squared and the bx, but I need the c. So I want to be able to fill in this plus space, this blank area here, with the perfect square that's going to make this a perfect square trinomial. And if you remember what I told you about this term here and this term here, it's going to help you out. Remember, I said it's going to be half. So this is going to be a -5 right here, or -5, because there's an x in front of it. That's what the squared term would look like. So what term would I put into this blank space? I'd put a 25. All you have to do is cut the middle term in half and then square it. So look at this one down here that has the 6x. Cut the 6 in half, it's a +3. I would actually like to see that little tiny parenthesis underneath your middle term when we get to the completing the square. And then square it, and you get 9. You just made perfect squared trinomials, which we could rewrite as a squared monomial, a binomial inside parentheses, and square that guy. Go ahead and pause your video here and see if you can fill in these 3 blank spaces. Okay, so what I would like to see is a +10 down here. Square it, and you get 100. A -2. Square it, and you get 4. This is the one that kids get a little crazy on because they don't like fractions, but to cut 5 in half, you just put 2 in the denominator, and to square it, you just do 5/2 times 5/2, and you get 25/4. Pretty simple to complete the square. So here are the steps that you have to follow to complete the square. The first step is to make sure that the number in front of your x squared is a 1. So if this isn't a 1 right here, we need to divide every single term on both sides of the equation by that number to turn it into a 1. It doesn't matter if it goes into them or not. You just make them fractions if it doesn't go into it. This first number has to be a 1, all right? And then if we have the c on the left-hand side with the x squared and the x, we're going to move it to the right-hand side to make sure that we have room for that plus space. And I want to see you put that plus space in there. But if you put a plus space on the left, you have to put a plus space on the right because an equal sign is a balance. We can't be putting something on the right and not put it on the left also, all right? And then we're going to fill in that plus space by cutting the middle term in half and then squaring it and put that number on both sides of the equation. Then we're going to rewrite it as a binomial squared, take the square root, and then find our answers for x. Let's do a couple of them. Okay, so here's our first example. So let's go through our steps. The first step is to make sure that this first number is a 1, which it is, so I don't have to worry about dividing. The second step is to move the constant over, the thing that doesn't have the x, to make room for our plus space, because I really want it to look like this. Because I feel it was pretty easy to fill in that blank. So if I move the -20 over, it becomes +20. Remember, we're just changing the sign when we move a term. And I put a plus space on the left, so I have to put a plus space on the right. All right. Then my next step is to cut the middle term in half. I would like to see you guys put that +4. I draw a little arrow, I put a little squared there, so I know that I have to put a 16 here. If I put a 16 on the left, I got to put a 16 on the right. And the reason I want you to put that +4 is because the next step is to write the binomial squared. And this term right here just slides down to there, and you put the plus 4 in. The term there should be an x, and then we get a 36. Well, look what happened. I have one x. That means it's pretty easy to solve. I just got to do SADMEP. I don't see any addition or subtraction yet. I don't see any multiplication or division. I just got to get rid of that square root, or the squared, and I do it by square root. On one side, they cancel out. The other side gets a plus or minus. And it turns out that 36 is a perfect square. By the way, that's kind of a giveaway that I could have factored this in the beginning. And I'm going to be honest with you. If I'm not asking you to solve by completing the square, you don't ever have to. It's not used all that often because we have another thing that we're going to learn in a couple days about solving quadratics that don't factor. That's a little bit easier. But sometimes completing the square is pretty easy. Like when the number in front of your x squared is a 1 already and your second term is even, completing the square is pretty easy. So let's finish this one up. Let's move the 4 over by making it negative. And remember, we put it in front of the plus or minus. Now, I would not take this as an answer because you can actually do these two things. You could do negative 4 plus 6 and give me 2. You could do negative 4 minus 6 and give me negative 10. If you wanted to go back and factor that, you would see the factors are x plus 10 and x minus 2, but you can just go ahead and give me the answers of negative 10 and 2, just like that. You could actually say x equals 2 and x equals negative 10 because we are not in the coordinate plane. There's no f of x. There's no y. So you can say x equals in this case. Or you could put those in braces. You'll see it sometime like this. Just don't put them in parentheses because it looks like an ordered pair, and these are not ordered pairs. Let's go ahead and try one that's a little bit harder. So my step 1 this time has to be done because it is not a 1 in front of the x squared. So remember, you can say divide both sides by 2, but to divide both sides would have to be one term, so I'd have to put parentheses around the trinomial. I don't want to do that. So a better way to think of it is to divide every single term by 2. Because there's an equal sign, we're allowed to do that. If there wasn't an equal sign, then we'd have to do something else, and that's for a later date. So really what I have here is I have x squared minus 7 halves x minus 6 equals 0. Okay? I'm going to go ahead and come over here and write because I might need some more room. All right, so my next step is to make room for my plus space. So I'm going to put that there, which means I have to move the 6 to the other side. Well, it's a negative 6, so on the other side becomes a positive 6. And there we are. I have my plus spaces on both sides. My next step is to cut negative 7 halves in half. Well, that's weird. I got to divide by 2. That's what cutting in half means, right? Well, I already have a divided by. That is really just 7 divided by 2. So if I want to cut negative 7 halves in half, I can just put another 2 down there. Really what I'm doing is I'm multiplying by 1/2. Instead of dividing by 2, I'm multiplying by the reciprocal. But if there's already a division bar and you want to divide, you just put it underneath the division bar. So I get negative 7/4 here, right? And then I'm going to square it, and that's 49/16. 49/16 on both sides. And then I can write the binomial x. That negative 7/4 just slides down, and it becomes x minus 7/4 squared. And then we go ahead and use our calculator here and get our answer. And that's 145 over 16. Now your calculator will do that for you. The only problem with using the calculator sometimes is it will reduce the fraction already if it is reducible. And we actually don't want that right at the start because when I take the square root of both sides, if I didn't reduce the fraction, that denominator is going to be a perfect square every time, which is what we like to see. So let's go ahead and keep going. Let's go ahead and solve this. I'm going to square root both sides. All right. And remember, this, I'm going to rewrite this as, remember, oh, don't forget the plus or minus, as a fraction with a square root in the top and a square root in the bottom. All right. That's the same thing as one big fraction underneath a humongous square root. I could write it as a regular fraction with a square root on top and a square root on bottom. And, okay, we're going to come up here. I get x minus 7/4 equals plus or minus the square root of 145. We have to worry about 145 a little bit because there might be a perfect square in there, but we'll worry about that in a second. And then the square root of 16 is 4. Now look at the denominators. If I don't reduce the fraction before I take the square root, the denominators will always be the same. And when they're the same, I can put them together. I change the sign. This is one way to write it. But when they both have the same denominator, you can write it as one fraction with a single denominator and do 7 plus or minus the square root of 145. I would definitely take this answer. You don't have to separate it and write 7 plus the square root of 145 over 4 and 7 minus the square root of 145 over 4 because 7 and the square root of 145 are not like terms. I can't put them together, so I can just leave it like that. Okay, there we go.